morning. Back live. Hi. So, plan for today. I'm gonna write a little bit on that article, check a couple of experiments, do a couple small things. I am getting ready to head out of here, spend a few days in Florida, and then go to Palo Alto. So, pretty much the main thing over the next few weeks. Got a couple articles to put out. I've got a few things to make sure are working on our servers. I have a few different research projects that we're in a good spot with, and we will. So yeah, we'll have like probably a pretty chill bit of time, but I still want to keep streaming, and I still want to like show off some of the things I'm working on. Here, let me grab this. We had a little bit of an interesting morning here. I guess Yatsine finally saw some of the RL stuff. I know he's been like doing RL things here and there, and he saw some of the recent stuff. So, yeah, thanks for the endorsement, man. It's a very nice bit of growth. Welcome, Majay. All right, so here's what we're gonna do. I am pull up a restream first of all, and I think we're gonna check the experiments just to see if I did anything. I kind of forget if I had stuff running. I think I had like a neural MMO run going, and then after that, we'll get writing a bit. This is still live. Okay, so I guess we'll see if this is more stable. Basically, I reduced the learning rate, and it doesn't look like that changed literally anything. Like, they're basically the same exact thing, and we'll see if this crashes or not. I guess there is, if we look at this right here, there's like a very, very slight difference in perf, but it's almost negligible. Yeah, that's gotta be like negligible, right? I guess it kind of slows. No, you know there is a difference. So with the lower learning rate, look at this. You see that? It actually doesn't do anything for 10 billion steps. Isn't that funny? So it just does flat and then this. That's kind of cursed. Well, we'll see if it's stable or not. And we'll see if this, like, jumps up or not. Whatever. But yeah, it's only 640 bill that it's supposed to run for, right? Eh. That's a soda model either way. Okay. I'm good with that for now. I've got all sorts of people messaging me now from those tweets. Do I even have? Hang on. Let me set a couple quick things up so that I can actually reply to stuff effectively throughout the day. And then I think what we're gonna do is we're gonna write on the quick start guide a little bit today. So if you guys are interested in helping shape the learning material that I'm putting out, because I don't do a ton of this content. I really don't do a ton of educational content. So if you want to help shape this little bit and make it as useful as possible to you, you'll be able to do that today. Welcome, Major. I just have to enter one thing here, guys, and I'll get started. Captures. All right. Cool. So let me see if there's any. It's like because there's like this massive blow up now that I'm just getting because of all of the new stuff, which is good. I got Yatseen looking through Hyperpram stuff as well. Alright, I did not intend to just like start stream and be handling DMs, but let me at least like it would be cool to have him doing some drone stuff around with us. It would be fun. Alright. People are noticing has been looking for cool projects for a while. Yeah, man, I hope so. It definitely helps. It's very cool because we get more open source stuff, we help the science, and also it does actually generate us like additional inbounds on clients as well, which helps. Because I would like to make this thing like a larger private lab where we can get more servers and fund more stuff. Okay, so where we left this off, where we left this thing off, I think I was 5 sections through. Yeah, 5 sections through. I'm trying to think how I want to position this. So, for new people here, does this sort of plan make sense, or is there stuff you'd want to see in here that's different? So, quick summary, advice so far, and this is linked to all sorts of articles in here. Super basic intro that has you build the simplest possible working thing. Some pretty accessible fundamentals. A still pretty dang simple, but at least kind of cool environment that you build. Start feeding in a little bit of the fundamental knowledge. Some stuff about how our infrastructure works, some stuff about general RL. And then by here, you're doing like a real project. Sounds good so far. Blow the cobwebs out of my head a little bit here. I have like multiple DM threads that I was expecting to like calm down. Whatever. So, Puffer Algo article. Let's go grab these. Let me see, what did I actually write? Because I have like a few different things. You like I think this is the main. Are there any of these that I want to link otherwise? Yeah, that take is kind of dated. Where's the 3.0 article? Oh, there isn't a 3.0. It's just, yeah, okay. It was the trailer. Cool, that's fine. These two are the same. That's why I've been confused and stuck here. Because it doesn't make any sense. Right? Yeah, this is like... I honestly think that these last ones, I kind of just wrote these at the end of the stream. And they don't... Like, the ordering and the sequencing isn't good. I think this is fine. We have you build something, that's cool. We give you a very accessible blog post that's a pretty short read. Make you read a little bit of code and build some more stuff. Yeah, my sequencing is totally off. I think that we don't give them this infrastructure here. I think I move this down, and I give these articles here. Okay. You know, I don't like that I'm giving people the PPO paper this early, almost, right? I'm kind of stuck. Actually, let me ask you guys about this. Okay? Let me ask you guys about this. What do you do about this? Okay? So, I've linked a couple blog posts at this point, even just one that aren't mine. Like I linked Carpathia's post, right? But pretty much the rest of all this material comes from me. So, like, I don't want to make the guide just like, hey, read all of my other stuff and you're good, right? Like, I want to link you to external formal resources, but the problem is, my stuff is literally way easier to understand than everything else that's out there. Okay? Like, let me show you the difference. This is where's my description of PPO? Okay, I just say, yeah, this is just vanilla policy gradients with generalized advantage estimation, which is just a fancy exponential reward discounting with a value function baseline, and it adds policy clipping. Like, I give you like a 3-sentence description that's like, this is what PPO is and how it works for the most part. All right? And that's like 80% of the actual intuition behind the algorithm is these 3 or 4 sentences. And if you actually look, I have more detailed content on my algorithms and stuff. But then the problem is, as soon as I link you to like an actual formal paper, okay, this is the difference. They're going to hit you with all this crap. All right. And the thing is, when I read this, like, I know that none of this shit even matters. Like, this doesn't even matter. You can ignore this. This is just a poorly written version of a different formula. And then this is like using fancy math to explain something that is basically 2 sentences in plain English with exactly the same meaning. Like, so I don't want to like confuse the hell out of new people to RL, because some people are going to come in with a math background where, yeah, this is easy, and some people are going to be like, what the hell is this? And the thing is, you do not need to understand this to understand the RL, so I don't actually know what to do with it. It can be referred to the materials. Yeah, exactly. So, but Spencer, this is kind of my goal here is to, and also, hey, how's it going? I hope you're doing all right with the Texas floods. I don't know if those are anywhere near you. I pretty much like, I'm trying to drip feed in content, but like, I don't want people to say like, don't worry about it. You don't need to learn it. You do need to learn this stuff at some point, but like, I kind of want to make sure that people have already seen, okay, I already can build awesome stuff. Now let me maybe go to learn some of the formalism. It's tricky to balance those two things. Also, I got us a bunch of cool inbound, so working on that. We're at 93.82 as well. Mid-moving. I'm building much more educational, and so do I. It's a little tough though, because like a lot of the questions that you ask, right? The thing is like, okay, how do I magically know the answer to everything, right? It's because I actually like I understand the actual fundamentals, right? Stuff should be referenced. I have that in the quick start guide. I'm kind of trying to give people an order, like instead of like reference this, reference that. I'm trying to give people a pretty strict prescribed. Do this, do this, do this, read this, do this, read that. Now you know RL. Congratulations. Okay, let me see if I can put it further down at least. The problem is I don't like that we have no references. Like outside of Carpathy's blog. Let me see how self-contained this is. The CS classes aren't going to help with the papers. The thing is, the main algorithmic paper, it looks like this. Also this. And this. Like, relative to how simple the idea is, it's a super dense paper. Like, actually, as far as RL papers go, this isn't even that bad. But, like, relative to how utterly simple the core algorithm is, like, this is a lot. Like, I don't want to link people that, but the thing is, I can't link you the article, like our follow-up to PPO without PPO. I don't think anybody has a good blog post on PPO either. Do I need to make one? I really don't want to. Let me see if I can link people a section of it, or I can at least tell people how to read it in a way that's not going to be this painful. Because I think you do need to at least see where like that there like this exists, but I think you'd need to not suffer. This is a difficult thing to do. It's tough here. It is really tough. The thing is, fundamentally, there's no way you can genuinely understand RL without being able to interact with the literature. What? Yeah, there's a difference between an avocado and a handgun as well. What's your point? Okay, what is the optimal point to start interacting with the literature? Built a couple small projects. The thing is, custom networks is not even in this. So custom networks is covered by the background material. Like CS231N, you should know how to build custom networks. It's definitely at least after you've built like one substantial project. I think I just need to prefix it with some stuff. I think I need to give him the PPO paper relatively early, but with the caveat that, like, the paper is a lot simpler than what is actually presented. Set a timer because I got a meeting. Try to get it done before then. Hey Boxen, what are we trying to do here? So, I'm trying to figure out how I can make this article actually good for people learning RL. the point is to understand PPO. I don't think you can avoid back and forth. Yeah, exactly. The thing is, it's like you can't really implement PPO. Like, implementing PPO is not a short exercise because, like, the very small details for which there isn't really any theoretical basis matter a lot in terms of whether it's actually going to work or not. I don't feel there's a place where they distill the high intuition. Yeah, exactly. It's clipped updates on policy gradients so that you don't go too far off policy. With generalized advantage estimation as a better form of reward discounting. That's all it is. this help? Okay, I think this is okay. We give you a build section. This is like a few hours worth of reading. And then I think you kind of have the background to do something quite a bit more substantial, and you should hopefully have enough intuition not totally mess stuff up. The rest of my quick start guide. Very relieving, actually. I opened PPO, saw the equation, was like, oh, okay. Much more adequate. Yeah, so this is the problem, Max, and I'm trying to make this guide actually pretty well just for you, in the sense. Like, it's exactly for you in that case. Because, like, this type of stuff sucks. And, like, I know what this is because I've seen this specific notation and this specific equation a bunch of times. But if I open a random RL paper that has, like, even the exact same thing or something very similar in a different notation, it will take me a couple of hours to figure out what they're saying. Sometimes it's because the math is actually very precise and very helpful, and it's just complicated. But most of the time, it's just because researchers like writing math for the sake of writing math. The actual math that you need to know, okay, so it helps to be able to understand notation enough such that if you spend a couple hours, you can figure out what they're actually trying to do with all the math, right? Like, that is helpful. But outside of that, the knowledge you need for RL is the same as the knowledge you need just to understand the fundamentals of deep learning in general. You need to know what a partial derivative is. You need to know what a matrix is. That's it. Able to understand all the mathy stuff for sure at some point, but not starting point. The thing is, you actually can build some crazy cool RL stuff before you even understand it. The thing is, the point of really getting into the RL literature is if you want to actually help us advance the core algorithmic research. That is the point at which you really need to understand this stuff. It helps generally, and like, I don't know, if you watch me debugging people's stuff in reinforcement learning, like, we'll always have contributors that'll show me a thing, and I'll just go like, oh yeah, do this, and it'll instantly work. That comes from a very strong grasp of fundamentals, plus years of practical experience. So like you do need it eventually, but like I don't write stuff this way. Right? I do not write this type of stuff. I will write the exact same content, the exact same information, but not like this if I can avoid it. The one exception, I did do this for the protein blog post, but that was because I was directly referencing another very heavy mathematical work. So like I did this thing, right? This is the background on the algorithm. And then I said, okay, this is our new function here. But that's about as much as I did. And the carbs paper that protein is based on is arguably much heavier mathematically than the PPO paper. But the idea is not that complicated still. Okay. So that's the first 5. Started with 5 sections done, and we have 5 slightly better sections done. I guess we have this paragraph as well that we're left over with. But once people have done a project, research applications infrastructure, right, are going to be 3 of them. I can make the last 3 sections a choose your own adventure. Let me grab more coffee real quick. So I know the last 3 sections are going to be advanced infrastructure, going to be advanced research, like how to actually get into research, and then applications. Oh, we have a fair few folks on YouTube today. Welcome, everybody. Yeah, if you guys are actually new or relatively new to RL, and you have ideas on things that you would like to see presented in this guide, that's why I'm streaming writing. Like, I wouldn't be streaming writing otherwise, right? So please tell me. That's why I'm streaming it. Let me get coffee. The YouTube chat is working, right? Because I don't think I've seen a single message from YouTube. Go test that real quick. Oh, it's not working. Wait, what? There's a message that just didn't show up. Sarang. I don't know why it does that. Now it shows up. Oh, was it just now? Okay. I read the TRPO one, and it is intuitive if you've done convex opt. Okay. Yeah, but here's the thing. Like, if you've done convex opt, then I don't have to worry about the math side at all, and I can just tell you, go read all these papers, right? And then the thing that we have to figure out is the engineering side. I'm writing a guide that's like, people start at different points, right? A lot of people are going to know either engineering or math, but not both. Teach us RL from basic to advanced. Yeah, but what's that mean, Sarang, right? Like, that's what I'm trying to figure out, like what gaps I'm missing and stuff. People have not done convex opt. Oh, I have a fun story about that. So when I got to Stanford, they brought us all into a big auditorium, and the president gave us this like long-winded speech about how Stanford students don't know how to fail, right? Like you guys have never failed at anything, and you don't know what that's like. So I took that as a challenge. So my winter semester, I enrolled in a full course load, plus 2 graduate courses, upper div graduate courses, one of which was convex optimization with Stephen Boyd, which is a notoriously hard class that has a 24-hour long final. The final is written to take you 24 hours, and you have 24 hours to do it. So yeah, I did not pass that class. No, there was not a snowball's chance in hell, but I did learn a bunch of cool stuff from it. Engineering is important. Math can be done by people like you. I'm not a good mathematician at all. Bruh. It was fun. I had a good time with that. I took the 24-hour final right as well. I think I might have gotten like one question mostly correct. It's actually one of my favorite classes though, because like the one thing I learned from convex opt that was really useful, Stephen Boyd gave a great introduction to Pareto optimality and sensitivity analysis, and I have used that everywhere ever since. It was like the one really accessible piece of that course. Also, the problem with getting too theoretical about a lot of this stuff, right, is you write this beautiful formula for constrained optimization with TRPO or whatever, and then it just doesn't work. Right? It just doesn't work. I remember that course was so funny. Boyd said he said that he used to make his final open book and open other professors. So you used to be able to go ask other professors for help with his final, and he said that he did this to screw with other professors because they could not take his exam. This is the reason I lean towards heavier engineering, is because basically I was very practical with like, all right, what is the thing I need to know in order to make the thing I want to work? And it was mostly engineering. At the time I finished this course, I thought SGD was trash and Newton's method is the way to go. Yeah, and then like I spent the next several years thinking that all optimization research was kind of just trolling, because really not much came out of optimization research for a long time. But then Muon came out of left field and ended up being a huge, huge improvement for RRL stuff. So, like, there's actually legitimate stuff in optimizer research. You just can't have anything that's like quadratic or n log n in terms of the number of weights, because like obviously, right? Did you take his course at Stanford out of curiosity? where I did my undergrad. I don't know if it's also online. Off to debug Poly Turing machine. Good luck with that. Holy, I think that's a new record. That's at least 15 people on this stream. Hey everyone, welcome. We are trying to finish this guide today so that you all will actually have educational material on RL. I don't do a ton of educational material, but it's been highly, highly requested, so I'm trying my best here. We're kind of uniquely positioned where, like, RL's actually really easy to get into with Puffer, but then bridging the gap between how easy it is in Puffer versus, like, how you interact with everything outside of Puffer is kind of hard. Welcome, Grant. Can you give us a glimpse of a prequel article just to... Yeah, so there are a few of them. There are, if you look on the docs here, or the blog, there's this quick start guide, which just has fundamental terms, some perspective, and some things that I use a lot. This is a lot about, like, intuition and how to view the field. Okay? This is a lot, and this links you to resources. This, like, gives you a lot of good resources to read, but it doesn't actually say, read this, then read this, then read this, then read this. It doesn't give you the introduction like that, which is what I'm doing now. And then the other article that I think will launch concurrently with this is we have my programming advice, which applies to people who've also been programming for several years, but just pretty much if the way that you see me writing code on stream looks weird, you should read this. And then there's How to Learn ML. This is actually really short because Stanford CS 231N is really, really good, and it's free online. And if you just take that one course, which is very accessible, you're kind of good to go. The only other thing that I added here, which is very important, is because you have to read papers in ML, like, you have to read papers, you must. I added this section here, which is, I think, sheds a lot of light on why papers are the way that they are and should make it a lot easier for people to get into reading papers. Thanks, yeah. I mean, because other than that, right? Some of the terms, welcome to spinning up. So spinning up is okay. Spinning up is pretty good. The problem with spinning up is it's like 10 times too much math, and, like, the code sucks. So it's really, like, the math is good, but you don't need that much math to get started. If you have a strong math background already and that helps you, then go for it. But if you have, like, either a more balanced background or a more software heavy background, it's not going to help and the code sucks. So that's tough. Have you tried SAC? I think people really only use SAC in robotics these days because their simulators are slow. I haven't actually seen, like, good evidence for SAC over anything else. The thing that people do, which is really crappy, is they always use steps for their x-axis. So even if one is 10 times slower than the other, they still use steps. Like, they treat data as holy, and, like, you can never get any more data, even though you can. So I don't think there's much to SAC. I'd have to look more into it. It's also, there's problem with discrete spaces, which is annoying. So PPO has been really good, but then our version of PPO is, like, our new algorithm is a lot better than PPO as well. And the key is that it's fast. I can guarantee you that nothing beats what we have here on speed. Like, on raw speed, ours is the fastest. If you want to get into sample efficiency, that's kind of the open area of research that I have to look into next. Uh, the literature out there at the moment is very, very bad, and the reason for that is obvious, right? So if you're doing this very sample efficient learning where your experiments are really slow, you can't run a lot of experiments, so you're kind of just screwed. So my hope is that what we can do is we can take like the off policy algorithms, we can run them in the very high data availability regime and see if the off policy algorithms do better when you give them a ton of data than on policy, or if they're kind of the same. And then when you crank up the data reuse, we'll see if they diverge and if actually you can use a lot more compute to get a lot better results or not. Like, good controlled experiments kind of just don't exist for this stuff. Let's say that the last three of these are going to be reserved for infrastructure, right? Research and applications. What other two things do I give people before then? Oh, you know what it is? You know what I need to give people at this point? It's core stuff, right? Like, let's say that this is going to be like specialty infrastructure, and this is going to be like specialty Watching from Kenya, welcome. I think we're not actually going to stick Impala on here. Impala's actually kind of bad. Is there any multi-agent? Well, yeah, there's going to be these. I think we'll order them. Are there other papers I should recommend people? Trying to think of the papers. Xland? Have a big project I'm working on and could use your knowledge or help? Sure, what is it? of these should I link somebody? And nah, because that's not one of mine. Holy growth today, my gosh. I think what we do is we link all of these, and unlike the original, we actually give reasons why you read these. I don't want to link anybody any of my own papers, to be honest. I kind of hate all my papers. Are there any that I think are kind of good? Not really at all, right? Is there a Neural MMO 3 paper? No, there isn't, right? I didn't write one. Maybe NetHack? I think this one's a good one to read. I'm trying to think if there are other papers that I really think, like, that should really be included. You probably should be linked DQN. Yeah, you should probably be linked DQN. Oh, Go, obviously. Where was the original one? Is it only on... Is this article not... Is it not on archive? Hey Mohammed, welcome. Your chat does work. Is this still useful? It's a pretty easy read as well, isn't it? I think this is probably the one to suggest people, right? Sent project details. Only take 1 or 2 minutes to build. Hang on. Let me see. I'm looking what you're... Yeah, I'm looking at it. What? Hey man, this doesn't make any sense. Yeah, if I have a .learn function that works on literally anything, then you've assumed the conclusion, right? There's not a single system in existence that works that way either. Like, you can't just tell an LLM to do that, for instance, and have it work. It'll just kind of spin its wheels and do nothing. Can't send links in chat? That's YouTube, Mohammed, not me. Just tell me what to Google or whatever if you want to link me something. YouTube just bans links, and I don't think there's an option to disable that. They do it to prevent bots. Yeah, you can either tell me what to Google or DM it to me on X or Discord. This paper is very good for starter. Definitive Guide to Policy Gradients. Who wrote this thing? Yes, layman. This? VMPO is irreproducible from what I know. Oh, you gotta be kidding me that they do this on page 3. Dude. Okay, so, like, I could read this guide, but, like, yeah, no, this is gonna make everybody, like, not want to do RL. Unless you really, really like math, like, this is just not... You do not need this level of math. Like, come on, this is not even, like... Why the fuck do they have integrals? Why have they replaced all the sums with integrals for discrete problems? It's like they tried to generalize it to continuous time or whatever, but it's not... Like, it's fundamentally not. Also, their policy gradients derivation is like 3 times longer than the usual one. Yeah, if you tell me you have to do this amount of math to get to reinforce, which is an algorithm that, like, doesn't work, yeah, I'd be out of here. You want to know something that's kind of funny? It's actually way easier for me to train... It's way easier for me to train people with a basic systems programming background for RL than it is for me to train people with a strong math background. Like, if you have a strong math background, you can go read all the papers and such. But RL is, like, it's so heavily dependent on the engineering and the implementations that, like, that ends up being the main bottleneck most of the time. Took me a week to get past the first 2 pages. Yeah, so, like, that's not productive at all. Like, that's basically academic hazing. Because the material's not actually that complicated. It's just they've written it in the most complicated way possible. Dang, I need to learn. Welcome, Nick. You're in the right place to learn. Everybody is in discord.gg/puffer. We have literally brand new programmers in there who have gotten to the point that they're actually pretty good in RL now. And then, of course, the people who come in with any sort of decent programming background do very, very well quite quickly. Okay, let's write the descriptions for these. There is suddenly, like, a gale outside. Yeah, it's been raining for 10 minutes and the entire yard is flooded. Crazy. think you should put more. Thank you. I haven't proofread it yet. I'm gonna put learning dexterity first because it kind of pioneered the method. Yeah. So I've got crazy lightning storm outside, so if I disappear, that's why. I have 2 free months, and I'm looking to contribute to Puffer AI. Where do you suggest that I start? I have a good RL and programming background. Depends on your interests. So there is heavy research side stuff to do. There's heavy infrastructure side stuff to do. And we're also looking for like applications that are going to be useful in a number of different areas. Okay, so on the research side, and this is a thing that I'm going to start doing quite soon, we're going to have a big comprehensive push to look through all of the 2020 era and before-ish offline methods and see if there is anything to offline methods. They're kind of a mess, and all the research in the space is like kind of a mess. So we're probably going to have to do some sort of version of Pufferl, which is our main trainer that does that stuff, and like try out all the different components and methods and see what matters and what doesn't. That's one huge thing on research side. Yeah, there's stuff on hyperparameter tuning and other things in research as well. I think that's the main big one, though. Let's see. On the infrastructure side, we want to actually get close MFU to what is theoretically possible, right? We want to get close to 1 on that, or 100, however you define it. We haven't actually done that stuff formally. As fast as Puffer is, I think it could be like 2 or 3 times faster yet again if we were to optimize that stuff. There is also other related infrastructure things we can do with optimizing data transfer from CPU to GPU. And then on the applications and environment side, there are a couple things there. On one hand, like, there's the idea of designing probe environments to help us with our algorithmic research. But then there's also the idea of, like, just going out and finding hard problems in industry that could be solved with FastSim and trying to do that. That is also the way that you get involved with the business side of Puffer. We do all the research is managed via the Discord, so discord.gg/puffer if you're not already in there. And then I stream, of course, as much as I can. Both research and application look interesting. I'll be more active on Discord from now on. Yeah, I mean, that's the main thing. Just like at me on there, and I usually catch everything unless people are spamming my chats. I think capture the flag was still 3v3. The 2v2. 3v3. Professor, I am not a professor. I am technically a doctor, I'm not a professor. You think that current phones and laptops will be so much better if they had local LLMs, natural lava quantized versions? Developers could just add useful features on top? Not really. Like, yeah, not really. You'd have to come up with something that actually lets you do that's interesting. Because right now, like, the have a chatbot assistant everywhere thing has really not been all that useful. I mean, I don't even know if it does anything if you have a good one, right? Like, if I give you O3 on a phone, does that actually do anything? advisor and coach knows the right thing to tell me in the moment. Yeah, the thing is that the LLMs, they kind of just lie half the time. So yeah. They're very good at giving you coherent sounding information that makes no sense. Like half the time you'll ask something that you can just Google and it'll just give you the wrong answer. Advisors and especially coaches aren't pure oracles of truth either. Yeah, no, but this one's particularly bad. I mean, I could see in a couple of generations them being very useful, but at the moment they kinda just aren't. Yeah, they just gaslight you. Exactly. They're kind of bad. Like, honestly, everybody shits on Perplexity, but I like the thing that they actually tried to do. I don't use this, and maybe I should. But, like, is the effect of counting rate in RL. So this thing actually gives you citations for stuff, which, like, they're not very good, right? These are really bad citations. But the idea of having, like, this is where this information came from. And I would like it to have it so that you can literally, it would quote the material from the specific source. Like, something like this is, I think, closer to what I would want. Because otherwise, like, the generations are just crap. Like, if this thing can go find me this information out of, like, textbooks and papers and stuff, and say, you know, here are these five different sources, they present this information this way, I'd be way happier, rather than it just being wrong. Pull in search results. Yeah, so they pull in search results, they all do this at this point, but then they get it wrong. Instead of retrieval augmented generation, I'd kind of prefer generation augmented retrieval. What's Carpathy's plan with Eureka Labs? ML only by LLMs? No idea. Sound like you're against LLMs or feel they're overrated? No, I mean, I think LLMs are very good, and I think that there's like a 1 in 3 chance that LLMs solve everything. They're just incredibly, incredibly overhyped right now, though, and it's like 99% of the attention and resources are on language models, when it seems like there's some pretty clear fundamental problems that we're kind of just all ignoring because that doesn't help us raise money. I do use LLMs in like a fair bit of my work. I just don't like copy paste blocks of generated code, and I'm very, very careful when I use them as sources for stuff because again, half the stuff is just wrong. Why 1 in 3? My personal best probability estimate. I don't know. What, do you think that's too high or too low? I mean, it's the fact that, like, humans are really, really bad at estimating exponential scaling. So, like, it is possible that a lot of the things that look like fundamental problems just disappear as you continue to pour billions of dollars into these things. And, like, the hardware also just gets better. So maybe we just end up with, like, a 10 trillion parameter model that's just actually amazing. Um, we haven't really seen these things work in any of the ways that like intelligence needs to work though. Like why the hell can't an LLM go teach itself stuff? Right? Like any reasonably smart person can go out and teach themselves something. Go learn quantum physics. All right. I will come back several weeks later with a decent knowledge of quantum physics. But like it seems like the LLMs it's kind of just what you do in pre-training and then you're stuck with that and there's not these things don't like recursively self-improve. And most of the works on saying that they do are like really, really bullshit. Like for instance, I think some of the stuff on like AI writing kernels is kind of interesting, but it's not that the AI is getting better at writing kernels. It's that just kernels are a pretty small constrained search space and they're kind of just running like exhaustive fuzzy search over kernels. But then like it's not like the model's actually getting better at writing kernels such that once it does search a bunch of times and writes a few good kernels, it's going to just start writing good kernels by default. Like that's how a low level dev is actually like trained, right? If you get a low level dev and have them write a few kernels, by the time they're on their 5th or their 10th kernel, they're going to be way better at it. What do you think about yeah, Ken Stanley's new thing? So Akarsh is on that. I know Akarsh. I have not had the chance to read that yet. So I'm going to have to go read that at some point. The things with LMs that we know is what we primarily focus on. How fast they can do things, and how they can do things repetitive. That's not really the way I look at things. Like, yay, we can maybe automate some repetitive language tasks is not why I get into RL or into AI in general. Like, I'm not really interested in just like taking the capabilities of stuff as it is today and like seeing the limited things we can do with them. I'm really more focused on how do we advance research and how do we advance the capabilities of AI in general. I don't even know if I have 3 sections here. I have a phone with a local LM. Africa. Is it? I don't see how that does anything more than like any of the free models now that are faster. Like you can literally get free models without a subscription right now that are better than Llama 3, right? Starting with deep RL courses on Hugging Face and read the RL book. Wondering on your opinions about this approach. Welcome, first of all. It's decent. I think you've kind of made stuff a little bit harder on yourself than it needs to be. The deep RL courses on Hugging Face, like the code associated with that is like SB3 is not good at all. And the RL book from Sutton and Bardo is good, but it's like a lot of very heavy theory that doesn't really show you like how to actually make RL work. So I would suggest to you, like, just honestly, go check out the stuff we're doing in Pufferlib now. There are a whole bunch of articles, and there's a quick start guide, and there's like a how to write your own environment. Like most of the people that are getting into RL, I just tell them to start writing environments because there's no better way to learn RL than to actually build a problem yourself and then make RL solve it from scratch and figure out like you'll see all the things that can go wrong with that as well. Um, You'll also be starting out from a point where our algorithms are actually pretty good, rather than most of the things in those textbooks, like they don't actually work, or they only work if you spend 3 months tuning them. The guide I'm working on right here is actually going to point people to a whole bunch of references, and I think that some of the stuff in here will be a very good entry point for you as well. What is it about ML and bad code? I mean, to be fair, kind of all like code almost everywhere is terrible. It's just that it matters a lot more that your code sucks in ML because you don't get an error message. You just get an agent that doesn't train properly and you don't know why. Models are cursed to begin with, and representation is fractured. Representation is fractured. Representation. Model representation is fractured. There isn't really a representation to begin with. What contains logical? Yeah, I'd have to look. You have to be careful with the neural nets getting too small, because when neural nets get too small, you start running into convexity problems that don't exist in larger models. Like, larger models can have saddle points and can have poor conditioning, but you don't really end up with, like, local optima as a problem. That's just not a thing. I have a meeting in, like, 10, so let me see what we can do here. It's a good thing to have done. I actually think we're going to just do advanced topics. Let's say, for example, I wanted to use GPT-4 to make apps for people just using prompts. Voice generator. That kind of stuff, like, I think almost works, but doesn't really work at the moment. Running into train test gaps and drive end, would a smaller model force it to not be able to memorize? Are you using all the maps, Spencer? You should just use all the maps for training. Just use all the data. Hey, welcome, Himanshu. I do have to run in a few minutes for my first meeting today, and I will be back afterwards. We're going to finish at least a first draft of the guide today. That is the goal. I got the full set, 10K maps. 100K is technically... Wait. You have 100K though, don't you? Did you train 100K or no? The beginner's guide on RL completed. I'm working on it right now. Programmer and ML we have a full draft of this. We have a full draft of this. It's 2K words. It's got my advice on learning programming and then all my advice on learning ML. Honestly though, the ML section is very easy. Like go take CS231N. It is available for free online with very good lectures. And then the rest of my advice basically just has to do with like how to think about reading scientific papers. Because once you take 231N, you know how to do basic projects, you understand the basics of deep learning, and the only thing that you need to know is how to teach yourself more stuff by like reading papers effectively in specific areas. Oh, GPT or heavily prompted Llama 3. Why can't you just heavily prompt GPT? I don't think Llama 3 is any good, is it? I mean, either of these, like, the thing is, neither of these are going to work at the moment, right? So, like, basically, there are a bunch of startups at the moment, like Replit and stuff, where they run language models in a loop in order to build applications, and they've, like, hacked a whole bunch of stuff to try to, like, make it sort of work. This type of stuff will eventually work out of the box, I think, on some of the big models, because it'll just be baked into the capabilities. But for now, like, you kind of just can't do this stuff with base models. And you can't do it with base models and prompting either, because the problem is not that you don't have a good prompt. The problem is interactivity, right? It doesn't have a feedback loop where it can build stuff and deploy stuff and check errors, right? That's the thing. Okay, I have to, I gotta run for a meeting in just a second here. So thank you to folks for tuning in. I will be back in probably like an hour, maybe less. And we're gonna finish this. So if you want to see me finish this, and if you want to, once I finish this, like look through this with me and figure out sections where things are not covered that you'd want to see covered in this, then you can join back in. Otherwise, Puffer.ai for all the things. If you want to help me out for free, for absolutely free, just start the GitHub repository. And if you want to get involved with development, join the Discord, discord.gg/puffer. Which models do you recommend? There aren't models that do the thing that you want to do at the moment that are not third-party paid services, Kamswa. You can also follow me on X for more RL content, where I stream a whole bunch of stuff, and I post RL articles and such.